Hello everyone. So in this video, I'm bringing up the questions related to DSA algo that were asked during Blinkit interview to me, and I will quickly share my introduction. So I'm Samacha Singla, and I have over 5 years of experience in tech industry, and right now I'm working at Angel One, and previously I worked at companies like Blinkit and Amazon. And in this video, I will be sharing my interview experience at Blinkit. And as I also announced on my LinkedIn profile that I would be sharing interview experience across different companies, which I have taken done in last 2 years. So stay tuned to see the interview experience at other companies. And I also have taken around more than 200 interviews while being at Amazon and Blinkit. So if you want help with any interviews related to DSL Go or tech design interviews, you can book a one-on-one here. You don't need to pay anything. It's just free. I take one-on-ones on Tuesday or Thursdays. So without wasting much time, let's move to the interview problems. So in this video, I will be discussing 2 problems that had been asked during the interviews. So let's look at the first one. So this is the first problem which was being asked at the interview. So let's quickly go through the interview problem. And generally, interviews don't share lead code link while they are sharing the problem. They modify the problem statement a little bit. If you are giving 10 interviews, I think there will be hardly 1 or 2 interviews where interviewer would be sharing the lead code link directly to share the problem statement, asks you to code there. So the chances are very less that you would be getting the problem statement exactly. There would be some modification in the problem statement, and they would be sharing the problem statement over a Google Sheet, or they will be dictating the problem statement. So it is very important for you to ask about the constraints and other parts which will help you solve the problem. So let's start with this one. This is the first problem in this video that I am going to cover. So you are giving an array of integers, positive integers, and you are giving an integer k, right? And you have to partition the array into 2 ordered groups such that each element is in exactly 1 group. A partition is called great if the sum of elements of each group is greater than or equal to k. So basically, you have to partition the array into 2 groups, and the sum of elements in those 2 groups, like the sum of group 1 and group 2. Each of them needs to be greater than k or equal to k if we are going to call them great partition, and we need to return the number of distinct great partitions. I will come back to this distinct part. What does this mean? And they are saying that answer may be too large, so return the answer after taking a modulo from this. Okay, so 2 partitions are considered distinct if some element nums of I is in different group in the 2 partitions. All right, makes sense. So let's look at the constraints also once. If you look at the constraints, so the array length and k are within 1000, but the value of one integer can be up to 10 to the power 9. So if you look at the sum of all the elements, it can be like 10 to the power 12. Okay, so let's look into problem statement. You are giving an integer array which has less than equal to 1000 elements, right? You are giving an integer k. Now you need to break this array into 2 sub-arrays, or basically 2 partitions. So that, let's say this is group A, this is group B, and sum of A needs to be greater than equal to k, and sum of B also needs to be greater than equal to k. Only then it is a great partition, right? And let's say your array has 2 elements, right? 2 and 2, and you're given k is equal to 2. So this is one good partition, right? And let's say you have another case where you have 3 elements in the array, and you have this k equal to, let's call this 3, let's call this 4. Okay, and here you are given k is equal to 2 is what you are given, right? So one way is you partition this way. This is first partition, this is second partition. So now there would have been one more way where you say, okay, first partition is this one and second partition is this one. So essentially what problem statement is saying from this thing is that these two ways of partitioning aren't different ways, they are exactly same, because one partition exactly matches here, right? So count them as one instead of counting them as two, right? All right, cool. So this is what we need to count, and you are given an integer array, as I generally create an array like this, right? And now what we need to do, like we need to pick each element, and we can either put it in the first partition or the second partition, and we need to calculate for the remaining elements, like what is the number of distinct partitions that we can create with such a configuration, right? So this is if you see how we are going to do this is like let's say you are at some index I in this array, right? And you are maintaining sum of partition 1 and partition 2, and you are at this element. So you have a choice whether you can add it to partition 1 or partition 2, right? And you will reach here. So you will eventually reach index plus 1 with either p1 plus a3, or your possible configuration is p2 plus a3, right? So you are solving it recursively. And if you spend some more time thinking, otherwise if you have solved a couple of DP problems, you would know that you can memorize this. So this is something related to DP. So using DP, how would you solve it? So simple way. So look at this. You start from the last element, which is essentially your n minus 1th element, right? And your partition 1 initially is 0, your partition 2 is also 0, right? And now what you do is you start from n minus 1th index, right? So you have this parameters, partition 1, partition 2, and you have the current index where you are. And what you need to do is you need to reach the all the way through the left, and at each step you decide whether you are keeping it at P2 or P1. So what you do is you add it to both P1 and P2 in two different solutions, and you make two calls to see what happens in the remaining of the array. And once you reach here, what you do is you compare P1 and P2, and you say if both of them are equal to K, then you basically return 1 from here when your index is, you can say, index is less than 0. So you would have exhausted the complete array. So now looking at this, what is the state in your recursion? So your state or the memorization state would be the index, because at any point of time you would be at index, some index, right? You would have the sum of partition 1, you would have the sum of partition 2 is what you are storing, right? So now look at this. What are the possible values of index? It is possible to have 0 to n minus 1, or you can say like this going to have a factor of n, and n is basically 1000 that you can give. Sorry. And if you talk about partition, so here you're keeping the partition sum, the number that are part of array, you are taking their sum. So essentially this can go to 10 to the power 12, right? And this can also go to 10 to the power 12. So your state would have this many possible variables if you try to memorize, n into 10 to the power 12 into 10 to the power 12. So this is a very big state. You cannot create such a big state in a memory, right, while you are solving a DP problem. So your the way you need to think is that your state variables, the combination of those variables shouldn't go beyond 10 to the power 6, and in some exceptional cases it shouldn't go beyond 10 to the power 7. But here if you see, n is itself 10 to the power 3, so this basically goes to order of 24 and 3, which is 27. So this is a huge state. So you need to think about a workaround now, right? So far whatever we discussed, I would suggest that this approach, even if it doesn't work, you need to walk through this during the interview, so that interviewer see your thought process, how you are thinking, how you are arriving on the DP state, right? And this is very important that you are able to see this part also, that the state is really big, and so that you can optimize this part. So what could be another optimization? So if you see this way, so look at total number of partitions which are possible. Okay, so total number of partitions which would be possible is, if you have this array, right? So from this array, what you can do is, for each element you have two choices. Either it can go to partition 1 or it can go to partition 2. So if you want to calculate the total number of partitions that are possible, or basically total combination of this partition 1 and partition 2, what you can do is, you just simply calculate the number of ways you can partition this array. The way you can partition this array is, you can calculate it this way. For each element you have two choices, right? For the first element you have two choices, whether partition 2. Again, for the second element you have two choices, right? So this way, for each element you have two choices, right? So it becomes 2 raised to the power n ways to partition, right? So this is the total number of partitions you have, right? Total ways to partition. And let's see how does it happen if I calculate total ways minus the ways where non-great partitions. Basically we are looking at how the state will look like if we solve it in a counter way. So total ways is very straightforward to calculate, right? But this total ways won't give you the distinct, because if you have such an array, see, you have array of these elements. So what are the ways to partition from this? So this has two choice in first choice. So these are two partitions, right? In one choice 2 can go here, in another choice 2 can go here, right? And now coming to 3, so 3 can either go here or it can go here, right? So that is how. So if you see, one option is this, right, and other option is like 2 or 3, then you have another partition and you have another partition. So if you calculate the number of ways with this is what you're going to get. You're going to get 4 different partitions, because 2 into 2 4. So these are the possible partitions. So if you see, this is not the distinct number of partitions. This is basically repetition, where each partition or distinct partition into 2 is what you are getting. So where it can go, in worst case it can go 2 raised to the power 1000, right? So again you will need to take a mode, and whatever total ways you are getting, if you want to calculate the distinct ways, is equal to total ways divided by 2 is what you would be getting. But what happens here is, this number 2 raised to the power 1000, this wouldn't fit in your integer constant, because integer is somewhere around 2 raised to the power 32. So you would be keep calculating it with mod on the way, because total ways mod this number which is given, you can do it. And division operator becomes a little complex in terms of mod. So let's come back to this part, how to solve it. But for now, total ways we know how to calculate. Let's see how to calculate that part where we say, okay, partition 1 and partition 2. We are calculating the ways where one of the partitions is not great. So for any one of the partition, the sum is less than equal to k. So how many ways for this? Because if you calculate it for one partition, you don't need to calculate for another partition. You don't care about it at all, because once you see that you are making sure one partition isn't great, then it won't be the part of your answer, right? Because for your count, both of the partition needs to be great. So let's see how do you calculate the ways in which you can make this partition as non-great, or basically sum less than equal to k. So you start from right, you go from right to left, so you have some index, and you are maintaining this partition, and you are going all the way to till end, and you are saying if your partition sum is less than k here, and your index is equal to -1 or it is less than 0, then you return 1, because you have found one way in which you can make the partition non-great, right? So see, what is the state in this case? Your state becomes this index and the partition, which is the sum, right? Again, index has variable still 10 to the power 3, and coming to the partition, what is the sum possible for partition? So again, it can reach 10 to the power 12, right? So total states will become 10 to the power 15. So how do you solve this part? Now see, in this condition, what you need to check is your partition sum shouldn't exceed k, right? It should be less than k. So you would have a stopping condition inside your recursive method, that if your partition is greater than or equal to k, then from there you return 0. You don't go beyond. So you are not storing the answer for those states where your partition sum is going to be greater than k, right? So essentially you are keeping upper cap here. You are saying that your partition won't go beyond k, because as soon as it goes beyond k or it becomes equal to k, you will drop that recursion there, right? So k's value is also 10 to the power 3, right? And now the number of states become 10 to the power 6. So this is one way to solve. And now coming to this, how do we calculate our actual answer? So the actual answer is calculated this way. You need to calculate total ways minus, what were you calculating? You were calculating total ways minus this part, non-great partitions, right? So what happens here is when you're calculating the non-great partitions, you are basically calculating the distinct ways to create a partition that it won't be non-great, right? And total ways had distinct twice, right? We see the repetition here. So what we need to do is to calculate our answer, we will multiply this part by 2, so that we would know, we would get that exact part. The difference that we are looking out is what we will get if we subtract this twice, because we want it to be repeated twice, since it is getting repeated twice here, right? So let's see how to code this part. Let's come to the implementation. So you would first see the length, what is nums dot length, right? And now you would also calculate the sum once. So sum would come as long, because it may go to till like 10 to the power 12, right? For num, which is part of your nums, you say, you add it to the sum, and you say if sum is less than 12 this k, then you return 0, because if the sum of your array is less than this, you won't be able to create two partitions in any way. So there would be 0 ways to create such partitions, right? And now you have this total ways. What you do, you define the mode also. Let's define it outside. Your mode is, this is your mode, right? So you need to do it for the n elements. For each element, what you are saying is total ways into 2. So you initialize it as 1 because it's a multiplication factor, right? And you just take a modulo. Now you have the total ways here. So we have the part till here where we are saying we want to calculate the total ways. And now what we want to do is we want to calculate the number of not great partitions, right? So let's write a method count, you can say non-grade, right? So what you need your array here, you need the index, and you need the partition sum which you have here, right? And let's create a DP here. So state of the DP, it's going to be the index and the k. And what are the upper bounds on this? Upper bounds are 1000, right? So what you do here is you say DP is equal to, you initialize it considering that. So it is really safe to take a buffer of 1 or 5 from the actual number while initializing this, right? So you say DP of I basically initializing the array. Okay, and now you want to initialize it. Say DP of I of j is equal to -1. So you have initialized your DP. So now what you do, you say if your partition sum is greater than equal to, you need to pass k also here. Okay, if it is greater than equal to k, then you say there are no ways to make this partition as non-grade, right? If index is less than 0, then you have probably exhausted your array and your partition is still less than k, so you return 1. Otherwise, another way is you say if DP of index and partition sum is not equal to -1, you return DP of index partition sum, right? So now you have used the memorization, you have the terminal conditions here. Now standing at this this index, so there are 2 ways to calculate. So you say number of ways is equal to, you say is you calculate first by doing, you just go to the left index without considering the current number. This is one way to proceed. In another way, what you do is you basically add the current number to your partition sum. So it will become partition sum plus nums of index. Okay, so there are 2 ways, right? And you would say number of ways could be really clear. So you take a mod and you return DP of p sum is equal to the ways, right? So this is the ways, and what you say here is int non-grade ways is equal to count non-grade. Okay, so this is what you do, and you pass the nums. You start from the rightmost index, you consider 0 sum, and k you pass as it is, right? And now what you do is you multiply it by 2, so that you are basically calculating the repetitions which are there in it. So you make it into 2 into mod, right? And now what you have basically here, so you have total ways, you have non-grade ways. Their difference is what you need to return. So you simply say total ways minus non-grade ways is what you return, and you take a mod of them, right? Now what's the problem here? The problem here becomes that total ways can be less than non-grade ways because you had been taking mod all the time, right, throughout your array. So what you need to do here is you need to add this mod to the total ways. Okay, so this is what you need to do. So let's do one thing, let's try to do a quick dry run on this part. So you are taking the length of the numbers, right, and you took the sum and you basically check. whether the answer is at all possible or not. Then you initialize your DP, then you calculate the total ways, and then you calculate the non-great ways, right? So non-great way is always going to return after taking the mod itself, and now you return this. You say, all right. So here you have your H conditions and utilizing the DP here, and you are calculating the ways, and then you are memorizing and returning. Let's try to run it. What does it say? Okay, it was expecting the semicolon. All right. So it is giving the correct answer for these sample cases. So in interview, what you can do is, you won't have this access to lead code. And even if you have the lead code access, this isn't the right way to do the interview to test your solution. You should be performing a dry run on 1 or 2 cases. And maybe if you're using an ID, if interviewer says that you can use any ID, I would suggest to use some ID where you can run your code and try to create a test cases on your own and then run it. Let's try to submit this, whether it works for all the cases or not. Alright, cool. So this solution worked for all the cases. Cool. Let me know in the comments related to this problem if you still have some doubts how we solve this problem, because this is a hard problem. If you look at it, you might need some time, and when you're looking at such problems for the first time and haven't practiced DP much, then these problems might be really hard for you. But I would say in terms of the practicing, if you have solved like the basic DP problems, and on the top of that you have solved like 20-30 DP problems, you would be able to think through it in interview. Because in interview, generally during DSA rounds, interviewers ask 2 problems, and this was just one of the problems which was being asked. So let's move to the next problem, which was asked during the interview. So I tried to search that problem on lead code, but I think that is a premium problem. So the problem was this: put boxes into the warehouse too. And if you open the lead code, this problem you won't be able to see, right? All right, but there's one portal where I was able to find this problem. It is this one. So let's go to the problem statement. What is it? And we will try to solve. So these 2 problems were part of the same interview. This was the first problem which was being asked, and this was the second problem in the same interview. So talking about the overall level of interviews, if I talk about the level in last 5 to 6 years, the DSA rounds have become really tough. Like 3 to 4 years ago, the problem that would have been asked from you would be either lead code, medium, or easy. Hard problems were really asked, and even if they were being asked, they were the popular problems that you would have practiced. But nowadays you would see hard lead code problems in most of the DSA rounds. So let's quickly go through this problem statement, and then we will see how to solve it. So put boxes into the warehouse. I don't know how the first part looked like. This was a problem which was asked. You are given 2 arrays of positive integers, boxes and warehouse, representing the height of some boxes of unit width and height n. Okay, the width is basically constant for all of them, and it's same for boxes and warehouse. Height of n room is in a warehouse respectively. The warehouse room are labeled from 0 to 1, from left to right, where warehouse I is the height of the ith room. Okay, so there are n warehouses. We are given the length, basically the height of each warehouse. The boxes are put in a warehouse by the following rule: boxes cannot be stacked. Boxes cannot be stacked means in one warehouse you cannot keep one box on the top of other. They need to be put sideways. You can rearrange the insertion order of the boxes. Boxes can be pushed in the warehouse from either side, left or right side. If the height of some room in the warehouse is less than the height of box, then that box and all the boxes behind it will be stopped before that room. All right. So this is a relatively complex problem. I think it is hard. Also not sure if you can see. All right. So the main challenge with this problem was understanding the problem itself, because what is the expectation or the understanding of the problem statement is not very clear from its description. So I had to ask the interviewer multiple questions to understand the problem statement, and I will share you a summary of my understanding what the problem statement actually is. So on the right side, you are given the warehouse, and you can assume that basically this is a building, and the roof of the building is like this, right? So each unit is a warehouse, right? And they have one height. So let's say if I talk about this orange one, this is a box. So their width is same. In one warehouse, you can keep one box in terms of width, and you cannot keep one box on the top of another. That's what it is being pointed out in the first point. So let's say you start inserting the orange one, this box. You can put it here, it will go, because you can start insertion from the left side or the right side. So if you insert it from the left side, it can go here. It can go here also, but you won't be able to move it here, because the roof or the height of this warehouse is small, right? So it will get stuck here, right? And if you start moving from here, so here you can put this, right? So optimal way to keep the boxes into warehouse is something that you need to figure out, because you want to put as many boxes, right? Return the maximum number of boxes you can put into the warehouse. So you have to find them in an optimal way, right? So let's say this example. So let's say if you insert this one first, right? This is the longest box here. So you cannot insert it from left, right? And now if you insert it from right, you can insert it here, but you won't be able to move it here because it is small, right? But now the point is, since you inserted this one here first, so this warehouse is blocked. You cannot move any other boxes inside, right? So you need to figure out in such a way that you are able to fill those smallest warehouses inside first, and then you are filling these ones, right? Cool. And you are given some constraints also, that warehouse length is n, and there can be n what is this? Okay, there can be 10 to the power 5 warehouses and boxes. Let us copy the constraints here, and we will copy one of the sample inputs also. Okay, so if you see where this problem comes, is it is not a straightforward move like you sort something and you insert. You cannot sort these things, right? Because let's say for this one, if you look at this example, you have this box which is as long as this warehouse, but you won't be able to insert it because the leftmost warehouse is small. Basically this left entry is less, and this rightmost entry is also smaller. So if you want to insert in any warehouse, so either on the left side or the right side, all the warehouses should be greater than that to utilize it to the fullest, right? So even though the height of this warehouse, if you look at the example, is 4, right? This has a height 4, and you also had a box of length 4, but you couldn't insert it here because you couldn't move it further from here or this side. So this warehouse, or basically this element, is constrained by the warehouses on the left side or the right side. So if you want to utilize the height of this warehouse completely, then either on the left side all the warehouses should be at least as big as this, or on the right side, because you need to come from one of the sides, and you would be able to move a box of 4 only if all the warehouses on this side are greater than or equal to 4, or on this side, so that you can move it. So what resolves here is basically, so for each warehouse, even though you are given some height, but there is some effective height which is constrained because of the height of warehouses on its left side and the right side, right? So if you see for this warehouse, its height is 4, right? If you start inserting from left side, what is effective height? Its effective height is 3, because you can the maximum height that you can insert here is 3, right? And if you insert from right side, so it has height 2, but it this warehouse had height just 1, right? So if you start inserting from right and you want to move till here, so the effective maximum height that you can insert in this one from right side would be 1, because the smallest height on the right side is 1, right? So in a way you can say that each warehouse has some effective maximum height which you can take, and it is basically you can see by calculating the effective height of the left side and the right side. So the effective height of this warehouse from right side would be the minimum height on the right side, and its effective height from left side would be the minimum on the left side, right? So once you have the effective heights of the warehouse, then this problem basically resolves into this part. The order in which you are inserting the boxes in the warehouse doesn't matter. You can insert in any order. All you need to do is you want to insert in an optimal way, so that you can utilize all the warehouses possible that you have and insert the maximum number of boxes. So once you have the effective heights of the warehouse, what you need to do is you just sort the heights of effective heights of the warehouse, and then you sort the heights of the box. Then you start from the smallest box and the smallest warehouse. If you are able to insert that box into the warehouse, you just insert it and go to the next box and warehouse. But if you're not able to insert it, what you do is you go to the next warehouse to see whether you can insert that first box into it. Because if you're not able to insert the current box into that warehouse, you won't be able to insert any boxes on the right in that warehouse, because your boxes array would be sorted, right? All right, so let's code this, and I will also tell you what is space and time complexity, because during interview, that should be basically your target to how compare different solutions using this. And there is something which interview also takes note. So you should generally talk about the big O complexities before starting the implementation. So if I talk about the big O complexity in our solution, what we are doing is for our warehouse array, right? We are calculating the effective height from left and right, and this you can do in iteration. You iterate from left to right once and then right to left once. So this part is big O of n. Then you sort your warehouse and boxes array, right? So this is your n log n, considering the warehouses n and boxes is of size m, and n and m are of same order. Cool. And now coming here, what are you doing next? So basically on boxes and warehouse, you would be using a sliding window or 2 pointers approach. So that will again big O of n iteration instead of n square, because you don't need a loop for that. So these are the operations that you're doing. So your time complexity becomes effectively this thing, big O of n plus log n plus n, which is, sorry, this is n log n, right? Which effectively becomes n log n, right? And talking about your space, you would be using additional space here to store the effective heights of the warehouse, right? So you would be using big O of n additional space. So these are the space and the time complexities of this solution. So let's code here. So you are given warehouses, right? Let's take this example itself here, and you would be having a boxes array here. Right. Now what you need to do, you want to calculate the effective height of the warehouses, right? So let's take this as warehouse length, and you create a new array, effective height is equal to new int of length and right. And now what you do is you say that min height that you start calculating from the left side, you initialize it as first element from your warehouse, right? And now what you do is so if the height of ith warehouse is less than minimum height, you say minimum height is equal to, right? This is what you do, so that by iterating from left to right, you are calculating the effective minimum height, and you say effective height of ith warehouse is equal to min h, right? And same thing you need to do from right to left. So you start from n-1, you go till you are at the first index. So now what you say you do is you say minimum height is equal to, initialize it as the last element when you are moving from right to left, right? And what you need to do is you don't need to create another array. You can store it within effective height, because you want to see effective height is basically you have two effective heights, one is from the left and one is from the right, and you will just pick the maximum of two, because you can either insert from the left side or the right side, and you would prefer that side where you can get more effective height, right? And same thing, you compare the height of current warehouse with mean height. If it is less than mean height, you initialize it as you basically set it as warehouse I. And now what you do here, if mean height is greater than effective height of I, you say effective height is equal to mean height. Okay, this is what you do. Okay, now what you will do is let's sort our warehouse array and let's sort our boxes array, right? All right, so now let's do this thing also. Your am will be boxes dot length. Okay, and now what you're going to do is you initialize box index is equal to 0, right? And then you iterate through your warehouse array I less than n, which is basically your warehouse array. And now what you do is and there is one more condition, this boxes index should be less than m. So if your current warehouse, your effective height of I is greater than or equal to the boxes at box index, then what to do is you are maintaining a count how many boxes you were able to place. So if your warehouse is greater than or equal to the box that you are checking, then you can place that box inside that warehouse, right? So increase the count and you increase the box index as well, right? And you say the count is the answer, right? So all right, let's print it here instead of returning. We won't be returning anything. And solution is your count basically, right? So let's run for this. What do we get? Let's see. Box index, what does it say? Okay, box index we also increase. Solution is 3. So let's see what was the solution for it. Is it the same one that we are 1 2? Now where is this example? 2 1 3 4 5 warehouse. Okay, 2 3 3. Yes, for this the solution is 3, right? Let's check for another one also. Warehouse is this one, and your boxes is this part. Let's run. What is the answer? Solution is 3 for this. Okay, so it says the solution is 4 for this one, where boxes is this and your warehouse is 3412, right? So let's see where it might have. So you are basically able to insert all of them except the biggest one, and effective height for this is 3. Let's print the effective height quickly. So you have 4 warehouses, 3412, and minimum height is warehouse of 0. Let's quickly print this. Effective height, and we print this effective height here, which is our edge. Let's run. What is the effective height? It says 3312. So it's 3, 3, it's 1, yes, and it is 2. Okay. And let's see. Now what we have here. Okay, so we have used the wrong array here. It should have been effective height. Alright, cool. Let's rerun this. Solutions for, let me comment it out. So the mistake that I made here is I sorted the warehouse array here, whereas we were actually using the effective height, because that's what we had to use here, because warehouse array won't be relevant from this part. Once we have effective heights, that is what we should be using to place the boxes. Cool. Let's check those examples again. So during the interview, this is something you need to come up with, the test cases, before submitting your solution to the interviewer. So this is also working fine. 3412 12234. All right, cool. So it is working fine. Let me know in the comments if you need more explanation over the solution of this problem, and keep practicing. You can book one-on-one with me. You can come here and book an interview counseling. You can share your interview experience, and you can take the feedback for your upcoming interviews also, and you can also connect with me for the mock interviews. Till then, keep practicing. Thanks everyone.